Deep in the center of our galaxy, there exist mysterious clusters of stars that defy explanation. They zip around supermassive black holes at incredible speeds, reaching nearly 10% of the speed of light. If you want to see a black hole tonight, go outside and look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun lurking right at the center of our own backyard. When we gaze at the stars in the night sky, we often see them as serene, distant points of light. However, some of these stars possess the potential to alter the universe in profound ways. When massive stars come to the end of their lifespans, they erupt in a breathtaking explosion known as a supernova. These explosions rank among the universe's most powerful events, often outshining entire galaxies for a brief period. Interestingly, supernovas have also left their mark on Earth in the distant past. One such stellar explosion may have even influenced the evolution of life on our planet. Approximately 2.6 million years ago, a supernova explosion took place relatively close to Earth, just 150 light-years away. Scientists speculate that this event might be linked to the mass extinction of large marine animals that occurred around that time. Fast forward to today, scientists are closely monitoring an infamous star you may have seen in the night sky, Betelgeuse. This star is located in the Orion constellation, marking Orion's right shoulder. But something unusual has been going on with this star lately. This red supergiant has been dimming frequently over the past few years, which might indicate that it's on the verge of going supernova. Betelgeuse is approximately 600 light-years away from Earth, meaning the light we see from it today left the star about 600 years ago. Interestingly, we don't know its exact distance, but it's in that ballpark. If Betelgeuse had already exploded in a supernova within the last 600 years, the light from that explosion would still be traveling towards us. In other words, it's possible that Betelgeuse has already exploded centuries ago, and we could see the explosion at any time, even tomorrow. When Betelgeuse does go supernova, it will be the brightest one ever seen by humans. So, just how bright will it be? Will it be visible during the day? Will it pose any danger? And why do recent observations of Betelgeuse challenge our current understanding of stellar physics? Scientists have just found something very exciting about this star, and they're claiming that Betelgeuse will go supernova sooner than expected. Stars like Betelgeuse go through phases where they burn different elements in their cores. Initially, Betelgeuse, like most stars, fused hydrogen into helium to generate energy. But after millions of years, it exhausted its hydrogen supply and began fusing helium instead. This process caused Betelgeuse to expand and lose some of its mass, which made its outer layers swell up even more. Scientists previously observed that Betelgeuse has left what's called the main sequence, the stage where stars like our Sun spend most of their lives. Betelgeuse is now in the late stage of core carbon burning. As it burns heavier elements in its core, the star becomes more unstable. Eventually, when it runs out of fuel, it will no longer be able to resist the pull of gravity and will collapse inward, resulting in a spectacular supernova explosion. Recent observations have shown that it has already run out of a key stellar ingredient, hydrogen. That means that helium inside its core has begun to fuse into carbon. This process would have caused it to expand and hypothetically slow down. But Betelgeuse is strange. It's spinning much faster than a star at this stage of its life, and under these conditions should, around 3 meters per second at its equator, it should be way slower. Astronomers have long puzzled over its curiously high spin rate. To solve this mystery, a team of astronomers led by Manos Chatzopoulos of Louisiana State University has offered a juicy new theory about the red supergiant star. They suggested that Betelgeuse may have gobbled up another star. Chatzopoulos' team proposed that Betelgeuse was once part of a binary star system. These star systems, where two stars orbit each other, are commonly found across the universe. In some cases, one of the stars is way more massive than the other and can, on occasion, slurp up its puny counterpart. When this happens, energy from the gobbled star transfers to the larger, hungrier star and can cause it to spin more quickly. To test this theory, The researchers created a series of computer simulations that revealed what would have happened had a star like Betelgeuse sucked up its stellar sibling. On the other hand, another new study argues that the mysterious rotation of Betelgeuse may be a cosmic illusion caused by its massive boiling surface. What scientists previously interpreted as rapid rotation may actually be an optical illusion caused by the behemoth's boiling surface. In 2018, observations of Betelgeuse collected by the Atacama Large Millimeter/Submillimeter Array ALMA telescope in Chile showed that the star was spinning at around 11,200 m/hour. But recently, researchers suggested that the ALMA observations may have been caused not by the star spinning, but by massive bubbles of gas rising and falling on the star's surface. When viewed using telescopes like ALMA, which are not as powerful as some other currently active telescopes, the rising motion on one side of Betelgeuse could be misinterpreted as the star spinning toward the observer, while a falling motion could look like the star is spinning away from onlookers. Computer simulations revealed that, unlike our Sun, which takes the shape of a near-perfect sphere, Betelgeuse's massive surface undulates like a shape-shifting blob as giant globs of plasma bigger than anything in the solar system rise and fall like bubbles in a lava lamp. While all these observations strongly indicate that the star is nearing the end of its life, recent research even suggests that it could be on the verge of exploding, perhaps even in tens of years. In a recent study, scientists have claimed that Betelgeuse will become a supernova sooner than expected. The authors of the paper are saying that according to observational data and modeling, Betelgeuse could explode sooner than thought. But this is critical. They don't know what stage of core carbon burning the star is in. According to some of the models that fit the data, carbon burning could go on for a long time. In fact, the researchers write that it is not possible to determine the exact evolutionary stage because surface conditions hardly change in the late stage close to carbon exhaustion and beyond. Astronomers can only see the surface, but what's happening deep inside the star tells the tale. So basically, we're back to square one. Betelgeuse might explode tomorrow, it might explode in tens of years, or it might explode in 1,000 years. But wait, a big question arises here. If Betelgeuse really did go supernova soon, would it have an impact on Earth? Studies indicate that we would have to be within 160 light-years of a supernova to cause harm. But Earth has suffered many supernova impacts in its history, and scientists revealed that some supernova explosions from more than 160 light-years away had an impact on Earth. Scientists at Lawrence Berkeley National Laboratory reported that a supernova explosion 41,000 years ago, at a distance of 250 light-years, could have killed off the mammoth. But luckily, Betelgeuse is so far away from us that even if it became a supernova tomorrow, it wouldn't have much of an impact on Earth. But are there any potentially dangerous supernovae within 250 light-years of Earth? Well, there is one star that could have serious effects on Earth if it becomes a supernova. The white dwarf HR 8210, only 150 light-years away, is hovering near the critical Chandrasekhar limit, which is the maximum mass for a white dwarf. But as part of a binary system, it is gradually accreting matter and gaining mass. Should it reach 1.44 solar masses, it will explode as a Type I supernova with potentially devastating effects for Earth. The timescale for this may be hundreds of millions of years, but its discovery suggests there may be other potential killers out there. For more on this and other cosmic mysteries, subscribe to Digital Discoveries.